Bismillahirrahmanirrahim. I'm JAVEED, I'm MALIK from Boys High School, Trehgaon, with the topic that is similarity of triangles. And this similarity of triangles can be stated as geometrical figures having same shape. Geometrical figures having same shape. Having same shape, but not necessarily the size. And the mathematical notation for similarity of triangles is like this, and it can be further stated as when the three sides of one triangle are proportional, that means in the same ratio to the corresponding three sides of the another triangle. So when the three sides of one triangle are proportional to the corresponding three sides of another triangle. Corresponding three sides of another triangle. And the second one is when the three angles of one triangle are equal to the corresponding three angles of another triangle. I write here the two most important things for similarity is when the three sides of one triangle, once they are proportional, that means in the same ratio with the corresponding three sides of the another triangle, then the two triangles are similar. And the second one is when the three angles of one triangle are equal to the corresponding three angles of the another triangle, then the triangles are similar. Let us have here the example of geometrical figures. If we are having line segment AB, and if this is of x centimeter, and once again the another line segment CD, and if this is of y centimeter, both AB and CD, they are the line segments, but AB line segment is having x centimeter length, while as CD line segment is having y centimeter length. So in terms of the length, both the line segments are varied. In terms of shape, both the line segments have same shape. So we can say line segment AB there is similar to line segment BD. Let's take one more example. If we are having two circles, if this circle is having x centimeter diameter, and if this circle is having y centimeter diameter, this circle is the smaller one and this is the larger one. This circle smaller can never superimpose the larger circle, but in terms of shape both are alike. So in terms of size they are different, but in terms of shape they are alike. So these two circles are similar. So there are different criteria for similarity. Let's take one by one. The first very criteria for similarity is side. This SSS, and it stands for side, and side. For further explanation, we need two triangles. Triangle A, B, and C. Next, P, Q, and R. Let's take this AB is having x centimeter of length. Let's take this as y centimeter of length. Let's take as z centimeter of length. Let's take this PQ as x by 2 centimeter length. Let's take this as y by 2 centimeter length. Let's take this PR as z by 2 centimeter length. Here, AB, it is proportional to PQ, and QR proportional to BC. We have to check them whether they are proportional. And CA, it is proportional to RP. It means AB is having x centimeter of length, while PQ, it is having x by 2 centimeter of length. This QR, it is having this BC, sorry, this BC here, and then QR. It is having y centimeter of length, and this QR, it is having y by 2 centimeter of length. Then CA, it is having z centimeter of length, and this RP, it is having z by 2 centimeter of length. This x and x, y and y goes, this z and z goes. So what we get? We get 2 by 1 here, 2 by 1 here, 2 by 1 here. As we know, P by Q whole divide R by S is equal to P by Q into S by R. S by R. So it means triangle this ABC is similar to triangle PQR. Once again, there should be one-to-one correspondence, PQR by SSS, or we can say this triangle, this very triangle is having ratio 2:1, or we can say it is 2:1. 2:1. This triangle is 2 times greater than this triangle, or we can say this line segment PQ, it is scaled up by a factor that is 2. Once we will multiply it by 2, and we will get the line segment AB. Once we will scale up this over Q by the same 2, we will get Y, and once we will scale up this over P side by 2, we will get Z centimeter. Let's take one more example. If we will have two triangles, if it is having 2 centimeter of length, if this is having 3 centimeter of length, and if this is having 4 centimeter of length, let us denote it as A, B, C. Let's denote it as PQR. And if it is of 4 centimeter length, if it is of 6 centimeter length, and if it is of 8 centimeter of length. So AB by PQ, QR by BC, AC by PR. Instead of AB, we will write 2. Instead of PQ, we will write 4. Instead of QR, we will write 6. Instead of, sorry, here, it is BC by QR. Instead of BC, we will write 3, and instead of QR, we will write 6. Then instead of AC, we will write 4, and instead of PR, we will write 8. And if we will get 1 by 2 here, 1 by 2 here, 1 by 2 here. So it means all are equal to 1 by 2. Or we can say triangle ABC is similar to triangle PQR. PQR, once again, one-to-one corresponds. It means triangle, this triangle ABC. Triangle ABC, it is scaled down triangle of PQR by a factor that is 1 by 2. That is 1 by 2. And this is scaled up and this is scaled down. Once we multiply 2 to this very triangle, we will get 4. Once we divide 2 to this very triangle, we will get the triangle ABC. So we can either stretch the things, we can either enlarge the things, but we have to keep in mind the common value. If the value is common, so we are dealing with the similarity of the triangles. If values are not same, if the factor is not same, so we can't say that triangles are similar. This is all about the first very postulate. Thank you.